This video is on operating with radicals. We're going to be adding, subtracting, multiplying, and dividing radicals. With adding and subtracting, it's just as if you were dealing with variables. Adding and subtracting radicals, you can only add and subtract if they are like terms, which means with regards to radicals, they have to have the like radicands, so they have to have the same radicands, but they also have to have the same indices. So the square root and square root means we could potentially add them together. Just because they don't automatically have the same radicand off the bat does not mean that they won't have the same radicand. These do have the same index. They are both square roots, so that means that we could potentially add them. So you do need to make sure you check this first if they even have the same index. If they don't have the same index, they will not be able to combine, but they could simplify. So with addition and subtraction, we're going to follow the same rules. We have to see if we can get them to have the same radicand. We need to simplify these first if possible, because right now they do not have the same radicand. So let's try and simplify the square root of 72. The square root of 72 can be written as the square root of 36 times the square root of 2. This is actually that first part. Plus, then we have the square root of 32. Well, the square root of 32 can also simplify. This becomes the square root of 16 times the square root of 2. So now these will simplify. The square root of 36 is 6, so technically the square root of 72 is 6 square root of 2, plus the square root of 32 becomes 4 times the square root of 2. They originally did not have like radicands, but now they do. They both have the same radicand of 2, and they both have the same index of 2. So they both have the square root of 2. Now this is very similar to if I were adding variables. If this were, say, 6x plus 4x, I would not change my x's. My variables would stay the same, just like my radicals. So what really happens here, this turns into the coefficients are what we combine. This becomes our 6 plus 4, and the like term they have stays at the end. The square root of 2 is what they have in common, so that stays at the end. So our answer is just 6 plus 4 is 10, and we keep our like term of the square root of 2. Now, you can always check your answers using your calculator by looking at the decimals. So I'm actually going to type in the original problem of the square root of 72. I do need to make sure that I get out of my radical or close my parentheses if it opened with one, plus the square root of 32. And again, I want to get out of my radical or close my parentheses. I'm going to press enter. I'm going to get a decimal. Now what I want to check is, does my answer of 10 square root of 2 have the same decimal? So 10 square root of 2 has the same decimal. So that means that I know that I have at least done this correctly. It might not be simplified completely, but it has been done correctly. So again, when you add them, you have to make sure you simplify to get your like radicands if it's possible. If it's not possible, then they would just stay separate. So if this had been 6 square root of 3 plus 4 square root of 2, it would have stayed just like that. It would have stayed 6 square root of 3 plus 4 square root of 2. It would not have gone any further. But because these are the same radicands, we can simplify this by just adding the coefficients. The like term stays the same throughout that problem, so that square root of 2 stayed as the square root of 2 for both parts, and when we put it as our answer. So we're going to do the same thing with subtraction. We can only subtract like terms, so like radicands and indices. So again, we have to look before we even begin anything, do these have the same index? This is 6 square root of 18, and this is 3 square root of 50. So they do have like indices, but right now they do not have like radicands. So we need to see if we can simplify this before we try and subtract anything. So 6 squared of 18, we already have a coefficient, but we still have to simplify the 18. So this becomes, we're going to have 6 times, because that is the original coefficient. This will be the square root of 18 is 9 times the square root of 2. So as we see, this is still 6 times the square root of 18, because 18 is 2 times 9, minus, I'm going to have my parentheses, because I want to focus on this part right here. The original coefficient is 3 times. The square root of 50 becomes the square root of 25 times the square root of 2. Because again, the original coefficient is 3, 50 is 25 times 2, and 25 is the largest perfect square. So now I want to simplify this aspect right here. This becomes 6 times, I'll actually write this in pink. This is 6 times 3 times the square root of 2, minus parentheses. We have the coefficient of 3 times, now our new coefficient is also 5 times the square root of 2. Now to simplify this completely, to get this all into one part to see what our radicals are, 6 times 3 is 18. We have the square root of 2 minus, because I'm gonna be taking it out of the parentheses now, 3 times 5 is 15, square root of 2, so that's still square root of 2. They originally did not have like radicands, but now they do. That means that we can subtract them or add them, whichever one it says. So what we want to do is our like terms, that square root of 2, will stay as the square root of 2. So again, this turns out to be, we're only focusing on the coefficients of 18 minus the 15, and we keep that square root of 2 because that's that like term. So our answer becomes 18 minus 15 is 3, and we keep that square root of 2. So I'm going to check my calculator again just to make sure everything worked. I'm going to type in my original of 6 square root of 18. I'm getting out of the radical, minus 3 square root of 50. I'm getting out of the radical, and I get this decimal value. Now I'm going to type in 3 square root of 2, 3 square root 2, and I get the same decimal value. That tells us that we did it correctly. It might not be simplified completely, but we did not get this value wrong. And in this case, the 2 is prime, so it cannot go further. So this is our final answer of 3 square root of 2. So adding and subtracting radicals is just as if you were adding and subtracting variables. They have to have like terms. So adding and subtracting is adding and subtracting like terms. Having the same radicand and the same index. Always check the index first, because if the index is not the same, they will not be able to be combined. Then once the index are the same, simplify them as much as possible to determine if they can simplify further and to see if they can get a like radicand. So that is adding and subtracting radicals.